Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Fikri Muhammad Naski, and I will present about our group project for digital signal processing. Alright, our project title is Performing Z Transform with FIR and IIR filter. And here is my group member, Khairudin bin Husaini, Ahmad Amirul Ashraf bin Osman, and me, Ahmad Fikri Muhammad Naski, Muhammad Dan Hazib bin Azmi, and Muhammad Fazal bin Osman. And our lecturer name is Dr. Nohafiza binti Ngajikin. Okay, first I will present about the FIR and IIR filters theory and concepts. For FIR filters and IIR filters are two widely used types of digital filters in signal processing applications. And for FIR, which is finite impulse response, filters generate their output solely based on the current and past input samples. Here are some key characteristics for FIR filters. Okay, first, FIR filters exhibit a linear phase response, meaning that each frequency component of the input signal experience in the same delay. This feature is beneficially in minimizing phase distortion when necessary. Second, for the stability, FIR filters naturally maintain stability since they do not utilize feedback. Last, the finite length impulse response. FIR filters are suitable for applications that require precise control over the filter response because their impulse response has a finite duration. Okay, for infinite impulse response, which is IIR filters process an infinite impulse response, meaning that the filter's output depends on both present and past input samples, as well as past output samples. The key of characteristic of IIR filter is include first recursive structure, which means IIR filters utilize feedback, resulting in more compact filter representation compared to FIR filters. Second, IIR filters often exhibit non-linear phase responses, which can introduce phase distortion in the filtered signal. Alright, the last, infinite length impulse response. The impulse response of an IIR filter extends indefinitely into the past, allowing for more effective description of certain filter features. Okay, we go to the introduction for our project. Digital signal processing (DSP) is essential in modern technology, allowing us to manipulate and improve digital signals. Filters, a key part of DSP systems, help us remove unwanted signals and extract desired components. For understanding filters is crucial for engineers and researchers in signal processing. This report presents a microcontroller-based digital filter simulator, offering a comprehensive understanding of DSP techniques and filter systems. Alright, filters play a vital role in DSP by manipulating and enhancing digital signals. They selectively adjust a signal's frequency, content, empowering engineers to achieve desired characteristic and enhance system performance. Filters are used in various fields like audio and video processing, telecommunications, and biomedical signal analysis. They enable noise reduction, signal amplification, restoration, equalization, and separation, ensuring reliable and efficient signal transmission and processing.
Assalamualaikum, my name is Muhammad Faiz Osman and this is the literature review. The paper that I have researched show that filters play a crucial role in channel communication by eliminating spectral leakage, reducing channel width and eliminating interference. Filters have various applications in data acquisition and analysis, including altering the frequency content of time signals. Different types of filters are used for specific purposes, such as anti-aliasing filters for removing signal content before analog to digital conversion, noise removal filters for eliminating high frequency noise, and drift removal filters for removing large offsets. Researchers have worked on design finite impulse response and infinite impulse response filters for signal filtering. In this research, Both FIR and IIR filters were employed to filter audio signals. Smooth window function were used in FIR filters to reduce response lag while maintaining limited ripples. Different filter types such as a high pass and low pass were used in both FII and IIR filters to establish pass bounds and stop bounds. MATLAB software was utilized to analyze and compare the performance of Butterworth filter. Filters effectively remove unwanted parts of the signal such as random noise while extracting useful component in specific frequency range. Okay, now for the problem statement. One of the main challenges in signal transmission is the loss of signal or degradation of audio and picture quality. To address this issue, finite impulse response and infinite impulse response filters are designed. These filters help to improve the signal quality by reducing noise, eliminating interference, and enhancing the overall audio and picture clarity. Additionally, the complexity and cost associated with transmitting and receiving equipment for frequency modulation can be overcome through the use of these filters. By implementing FIR and IIR filters, we can mitigate the deterioration of the original signal at the receiving end and minimum problems related to signal qualify on our device. And for the objectives of this project, the objective of this project to develop a microcontroller-based digital filter simulator and analyze its performance. Firstly, we aim to understand and explain the digital signal processing techniques used in the simulator. Secondly, we will construct the simulator by implementing the design system on a microcontroller board. Finally, we will analyze the result by comparing the filtered signal with the unfiltered signal, evaluating the effectiveness of the digital filters in improving signal quality and suppressing unwanted components.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name Ahmad Emro Ashraf Osman. Okay, in this section, we will explain about the method that we use in this project. So, we use microcontrollers such as Arduino Uno and software such as MATLAB to design the digital low-pass filter system. MATLAB is a high-level programming language and software environment specifically designed for numerical computing, data analysis, and visualization. In MATLAB, the filter design began by determining the minimum filter order required to meet the specification using function. The filter coefficient derived from MATLAB were imported into the Arduino program once it was created using the Arduino IDE. The input signal source was connected to the Arduino's analog input pin and the output signal was observed using an oscilloscope or other measurement device. Okay, next, this is the flowchart for our project. First, we must understand the filter system and FIR or IIR filter. Okay, next, we must specify the desired cutoff frequency for the low pass filter, and then we design the filter in MATLAB. After we design it, we must upload the filter coefficient to the Arduino Uno, and then the Arduino Uno read the input data from the sensor signal source that connected to the Arduino. After that, we apply the low pass filter to the input data using the Arduino Uno. And lastly, we plot and analyze the filtered data in MATLAB. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Today we will present about result and analysis for coding for Arduino IDE software. So this is the coding in the Arduino IDE software. Arduino IDE, that is the full coding that we use for our group project. This coding is to insert the finite impulse response, which is FIR, and infinite impulse response, IIR, into the Arduino IDE software. In this coding, we change the value of cutoff frequency and sample frequency until we get the smooth sinusoidal graph. The value that we use for the cutoff frequency is 30 Hz, and for the sample frequency is 1 times 10 to the power of 3. Okay, next is the blue color waveform above show that the result before IIR filter inserted into the Arduino IDE. The graph that we get is not smooth. The maximum value of y-axis is negative 6294.88 and the x-axis is 1234. Okay, for the orange color waveform above, show that the result after IIR filter inserted into the Arduino IDE. So the graph that we get is very smooth. The maximum value of y-axis is negative 62980.49 and for the x-axis is 1238.
Assalamualaikum warahmatullahi wabarakatuh. My name is Khairul Nabi Hussaini and my matric number is AE20013. Today I will present about MATLAB simulation, and in this MATLAB simulation we have a full coding to insert the FIR and IIR filter. So in this coding we have changed the value of cut-off frequency and sample frequency. For cut-off frequency we use 300 Hz, and for sample frequency we use 800 Hz. Next, after do the simulation and run the coding, we get the IRR result. In the result, we can see it's shown the graph magnitude versus frequency and first frequency, and this is a good result for me. Okay, next, we also get the FIR result for this simulation. In this result, we also get the graph magnitude versus frequency and phase versus frequency. And this is also the good result for FIR filter. So that's all from me. Thank you.
Okay, we go to the conclusion for our project. FIR and IIR are two commonly used in digital filters in signal processing. They have distinct characteristic, implementations, and applications. FIR filters offer stability, linear phase response, and design flexibility. They are easy to construct without feedback and are inherently stable. However, they can introduce phase distortion in the passband when using a sufficient number of taps. On the other hand, IIR filters use feedback and recursive structures, resulting in more efficient design with fewer coefficients. They provide computational efficiency and are often preferred for applications requiring high frequency selectivity. However, they may introduce nonlinear phase response and have design constraints like stability issues and the possibility of response or instability. In summary, FIR filters excel in stability, linear phase response, and design flexibility, while IIR filters excel in efficiency and frequency selectivity. The choice between the two depends on the specific needs of the application, including considerations of phase preservation and available computational resources.